Hi, this is our early prototype of a lung ventilator called the Breezy. So you can see all the parts mounted here on this board, and the pressure supply, pressurized air is taken from just a standard home compressor, which is not used for breathing. So this is only for our demonstration and prototyping. Here you can see artificial lung. So this is our patient being ventilated, and yeah, there is a control panel here. And then we have another control panel on Android phone, which provides also a graphical representation of values. Right, so let's get closer. We have a pressurized air which is supplied at this time to both inputs, to both inlets. So one is for air and one is for pure oxygen. These two valves are used to control the air to oxygen mixture, or FiO2. Then the air and oxygen comes to the further stage where the pressure is being measured by the pressure sensor here. It's just this small one, and there is a line going to the flask. So this bottle is used as a reservoir into which we prepare the proper mixture of air and oxygen at the desired pressure, and then as another solenoid valve is used to control inhalation. So the inhalation starts or inspiration starts by opening this valve when the air goes from the flask through these tubings up to the patient's lungs. There are two sensors here. There is a pressure sensor which is used to monitor maximum pressure and peak pressure, and there is a flow sensor here. This is actually a medical flow sensor which works on the principle of heated element. So this flow sensor is used to calculate inspired and expired volume. We have a control board here. It's an Arduino board from 3D printer. There is a 3D printer board which we use only because it is easier to attach this control panel. This is a standard control panel from 3D printer, but we add 6 potentiometers so we can easily adjust parameters of the ventilation. And there is a power supply. There is a 12-volt power supply to supply power to the solenoids mainly. All right. So we can see at the panel there are many values being measured. So the first 5 rows are the 10 parameters. There are pressures, volumes, which are commonly used at the medical ventilators. And then we have 6 parameters which can be controlled by the pots. So we can see the maximum pressure is controlled by this one, peak pressure by this one, tidal volume by this one. Then there is inspiration to expiration ratio by this one, respiration rate, and FiO2. So now we can see there is a respiration rate of 20 breaths per minute. And yeah, the actual respiration rate is here. So you can see it is close to the set value. So let's try setting respiration rate to 12, and we will see what happens. We can hear that the breathing process has slowed down, and also probably the values of minute ventilation will be lower. We can also change inspiration to expiration ratio to see what happens, and we can also have a look at the charts of what these changes do with our breathing cycle. So now I will change the inspiration to expiration to now it was 1 to 3. Now I will change it to 1 to 2. So the respiration rate shall remain constant, and what happened is the inspiration, the pulse after inspiration has prolonged, and the pulse after expiration, or the PEEP pulse is shorter now. All right. And we can also try setting some different tidal volume. So I will change the tidal volume to 200 milliliters. And now we will see that really the volume being inspired is lower, or the inspiration cycle is very short. Right. Regarding the mixing of FiO2, the principle of mixing is by time division of the first two solenoids. So the time required to fill the bottle is divided into two parts. So first the oxygen comes into the bottle, and the increasing pressure during filling of the bottle with oxygen is monitored until some certain division of pressure is reached. Then the oxygen value is shut, and the air valve is opened, and again we are filling the bottle until we reach the final target pressure. Right now the bottle target pressure is 200 kilopascal. This value is currently fixed, and so it's hard coded, and it might be our next development of this ventilator to develop some algorithm to control some optimal value of the bottle pressure. This ventilator can run on the Arduino itself, and it doesn't require this smartphone to be attached to it. So the smartphone is used only to better interpret the values being measured in time, and to display more clearly what is going on. But there are no controls on the app, so the app cannot set any target to the ventilator. Everything is controlled here at this control panel.